Welcome back, yet another afternoon session. Those are your thoughts, and you'll be continuing the next break, but not until we hear these two wonderful talks. First, given by Lionel Robert, who's a professor of information and associate dean of ICT development and faculty affairs at the School of Information, University of Michigan. He's presenting a talk on the multi-study analysis of comparing human-robot trust using theory of mind information. Welcome.
Thank you. I want to start by first acknowledging that this work was led by my PhD student, Esterwood. He's not here, but he's the one that led this as a collaborative effort, but it's his work. So I sit in two places at the University of Michigan. One place is the School of Information, which, if you know about School of Information, very human-centered. We have a diversity of research approaches, ethnography, big data, lab, you name it, right? And then I have another appointment in the robotics department, which is in the College of Engineering, and not so much at all. They're pretty much engineers. They just realized that humans are around. They got to acknowledge them. And they begin the process of looping that in, right? So I straddle both worlds. My actual background is from the Kelley School of Business at Indiana, information systems. So I come from different backgrounds, different places, move around a lot. So I want to talk to you about trust repair. And so basically, I get a lot of phone calls from people in interviews about the fact that robots are going to take everybody's job, right? You think robots are going to take everybody's job, blah, blah, blah. And I said, no, it turns out that humans are pretty useful, right? So you have this combination of basically robots are really good at doing the same thing over and over again, picking up heavy materials. Humans are pretty good at ad hoc, creative, and problem solving. So the future is a hybrid workforce. An integrated hybrid workforce, right? The combination of both of these things. So that's the idea. And one of the challenges are trying to integrate this hybrid workforce. I know people at a major retailer that employs robots in their warehouses, and the biggest problem they have is that the human employees don't feel comfortable around these robots. They don't feel psychologically safe. They just feel uncomfortable with these robots all over the floor everywhere, right? And I tell people that we've learned in organizational research that people may take a job because they need the money, but they come back to see their friends, right? So these social relationships are very important, right? And a big element of that is trust. So we already know that. But humans and robots can both make mistakes, right? Now, the idea of trust repair is that, robots can make mistakes, and how do you rebuild trust? Now, the first thing that might go to your mind is, wait a minute, if the robot makes a mistake, pull it off the line and fix it, and it's back to working again, right? Perfectly, right? Not really. So if you talk to Google and the like, they're developing these robots that they will perceive as having general intelligence. So right now you have a robot, comes out of the box that can do 10 tasks. If you needed to do an 11th task, you would go and buy another robot. In the future, what they're hoping to do is to deploy these robots in the factory, warehouse, and your home. And if you needed to do an 11 or 12 task, it would teach itself. It would self-learn the task through a series of trial and errors, right? So you might think, as technology gets better, there's less errors. No, as the technology gets better, we push the boundaries, right? We actually do more and more things. So there would never be a time where we get to a point where there's no error in the technology by default, by design, right? Because the minute it learns something really well, we sort of push out the actual boundaries. So this is not a case of simply taking the robot offline and fixing it and having 100%. Now, what happens when trust is violated? Well, a question you might ask is, why is trust repair important? Well, why is trust important? Trust enables collaboration, cooperation, for example, communication, and coordination, right? So the question becomes, how can we repair trust? So imagine a case where robot learning new tasks, it tries out, it makes several mistakes, and then all of a sudden it actually learns how to do it, but now the human's lost trust in it. What can it do to repair or regain that human's trust in it, right? So let's, so like any academic, I'm going to come up with a set of shared concepts so we all know what we're talking about, at least what I'm talking about. So I define trust as a willingness to be of a party to be vulnerable to the actions of the other. Common term, trust violation is a failure to follow through on the expectation, and trust repair are efforts undertaken by trustee to restore trust following an actual or perceived trust violation. So we also understand what I'm talking about. So in the literature and human robot interaction, there are 4 commonly used trust repair strategies, or as I like to say, 4 ways to forgive your robot. But actually, the first one is apology. So imagine the robot makes a mistake, it apologizes, right? We've all had to apologize, right? Especially remorse and regret. The second one is denials. It can literally say, "Oh, it wasn't me." Remember that song? It wasn't me. I mean, sort of the same thing here, right? There's a mistake made, I guess, but it wasn't me. I didn't do it. And then there's explanations where it can basically explain, "Okay, here's what happened." You know. Then there's the idea of promises. Okay, I'll do better next time. Like, these are the these are the 4 commonly used trust repair strategies in the HRI literature today.
Denial doesn't work for people either.
Well, sometimes. So in the HRI literature, we didn't find a lot of theory. So of course, as an IS professor, what do? You make some. So we created this, I use the term theory very loosely, but we're just integrated frameworks that we have this around. We see this as sort of the theory of forgiveness, where basically you ask people, to forgive what you have done. And we think apologies is one example of that. Then there's the theory of basically forgetting or looking forward. Like saying basically, let's just talk about what we're going to do tomorrow. Right? We think promises are a good example of that. Then the last 2, one is the theory of informing, and we think this could be both explaining and denial, because if I didn't do it, I didn't do it, right? And also the theory of misinforming, right? And that could be an explanation, it could be denial, but it's not true, right? So you can imagine I could deny something and it's not my fault, that would be informing. I could deny something and it's my fault, it'll be misinformed, right? These are the theoretical bases. So here, so basically, my student came to me and said, "Oh, I'm interested in human robot trust repair," and I said, "Okay, it's like, okay, what do we know about this topic?" I was like, "Oh, nothing." It's like, "Well, probably not. Can you do a lit review?" And so we actually did a lit review, and it turns out there's sometimes they actually work, right? Sometimes they actually don't work. Sometimes they make things worse, and sometimes it depends on a lot of different things, right? So we actually reviewed the literature. Some of the things that we realized that we don't know. Most of the studies looked at one-time errors, right? There's not a lot of studies on repeated errors. It's unlikely that anybody makes, or any robot makes, one error only, right? More likely they'll make more than one error. 2, they actually, in many cases, they don't really focus on understanding when a particular strategy might work and when others may not work, right? So this is like our first starting off a couple of years ago into this space, right? So it started off here. And so the second thing we did was we built this online platform that's open source, right? And so I'm going to show you the platform. If you can download open source, we actually have a video of it, clip that I want to show you, gives you a little bit more background before I go in detail of the platform. So that's Warehouse Sim. I'll give you a little background here.
This is where the Warehouse Robot Interaction Sim comes in. Developed in the Unreal Engine, it is an open-source immersive virtual platform designed specifically for conducting research on trust repair in HRI. The platform is highly customizable, allowing researchers to adjust and modify it to suit their specific research questions and study designs. Researchers can change the reliability of the robot in the study, the robot's physical form, and how the robot communicates, with 4 pre-existing communication options programmed into the platform. This paper presents an overview of the platform structure, how it can be modified.
We published and at HRI a example or a small paper on it. And so here we go. Right. So basically, this, you can download this. You can make adjustments if you want. You can change it. Everything is in there for you. You just can't sell it. That's the only thing. Right? Yeah. But you can download and use it. So, and so how this thing is
We'll
set up.
apologize.
You apologize?
If we steal it, we'll apologize.
It's okay with me. It's the University of Michigan that has like IP. We have to do an IP sign before we drop it. So this is a game. So someone said earlier, how can you study trust without risk? Right? So this platform has a game, kind of works like this. A robot picks up a box, and so the human robot gets points for every box they load on the conveyor belt that goes to the truck, right? And the human gets a bonus for every box they load on there that's correct. So so the actual robot will dig and find a box, show it to the human. Human will go match the actual number of the box with the number on the screen. If it's yes, they get yes, and it's low, they get 1 point. Now, there's all this trade-off because if it's a bad box, they don't get a point, right? They actually lose a point. And there's the issue of time. So theoretically, if you trust the robot, you can just get yes, 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 get a lot of points. If you don't trust the robot, you got to take your time and read every number, you get less points. So the issue of a trade-off, right? So humans encouraged basically to go for. Make sense? You kind of look like you're not buying. Okay. Right. So it kind of works like this. So here are the actual conditions we have in there. So there are 10 boxes, right? Box 1 and 2. Then there's an error or not. Then there's box 4 and 5, error or not, 7, 8. And you can change the order. But for the study, we kept it consistent, right? So here are the conditions. There's the perfect condition. It doesn't make a mistake at all. It's perfect. Then there's the error with no repair. It makes the mistakes, but it doesn't say anything. It doesn't do anything. Right? There's no repair. Then there is the error and apology. So every time it makes an error, it apologizes. It says, I'm sorry, I got the wrong box that time. So we have a set where basically it says it verbally and it displays on the screen. It's set up to run in a virtual reality Unreal Engine, but you can run it online. The actual data I'm going to show came from online because we actually ran it toward the end of the COVID-19 thing, so we couldn't do it face-to-face. But it's actually built to run in a virtual reality. It has sound and everything. It kind of sounds like you're in a warehouse. All that's basically piped into there. Then the error denial was like, I picked the correct box that time, so something else must have gone wrong. Right? Denial. The other one is destination. Oh, I see that was the wrong serial number. And then here's a promise. I'll do better next time and get the right box. Trust repair. Those are the actual conditions. Now you may come up and say, well, Lionel, got one problem here. Got one glaring error. It's the virtual reality, man. It's not the real world. Like, what do people behave differently, right? I began studying autonomous vehicles and the issue of trust. And people say, man, you're finding ways to increase trust in the AV, but it's in a lab setting. In the real world, no one's going to trust these things. Turns out the opposite is true. The biggest problem we have with autonomous vehicles are over-trusting, right? So, but nonetheless, there's using a virtual platform have several benefits. Better for control, to replicate. You can actually make the interactions more realistic. It is very difficult to make an autonomous robot in the physical world that works the same every time, right? To make it truly autonomous. Realistic environment, so you can change the whole background and context. With a real robot in the lab, you're pretty much going to be in a lab, right? And there have been multiple studies that have shown that people behave the same in a virtual reality as they do with a real physical robot.
Is there a difference to call it virtual platforms or virtual reality, or is it the same?
It's the same for this presentation. Is it okay? Yeah. So, I mean, it's virtual in the sense that basically you can immerse yourself into it. But yeah. So I don't, yeah. So, I mean, there have been at least 5 studies, actually 6 of them, that's one's coming out, where people have run studies to see if there's any difference. They haven't found any differences yet. It doesn't mean they don't exist. It just means there's some validity, to using these virtual environments. So I'm actually wanting to present two studies. The first study was going to be is on mind perception. And this paper is under review at an unnamed journal. There are 3 reviewers. 2 of them love it. They loved it from day one. They just love it. And that's one reviewer who like, oh, can you put this in there? Then the next round, why'd you put that in there? Right? So yeah. So I just want to say, if you're that 3rd reviewer and you're in this room, I know who you are, and I'm coming for you. And the second study was basically looking at a trust repair and similarity. The idea is that if the human perceived the robot as being similar to them, does that impact the effectiveness of trust repair? If we have time, I'll show you the preliminary results of that study. So with study 1, does mind perception toward a robot impact the effectiveness of a trust repair strategy, and does this change over the repeated trust violations? So what is mind perception, right? The degree to which humans attribute mental states such as emotions, intentions, or beliefs to others or non-human agents. So the idea, so there's 2 types of this in some literature. The experimental mind, the idea that the agent is capable of having feelings, sensations, emotions, desires, and beliefs. And the agentic mind, the idea that the agent is capable of learning, observing, learning, remembering, and independent decision making. So this kind of goes back to your earlier comment where, have you ever tested to see if people actually see these things as being able to do these human type things, right? This is kind of where we're going at here. And and this comes from the theory of the mind. Has anyone been familiar with the theory of the mind? It's kind of popular, which is why I want this paper to get published soon, right? But the idea is that it's from the assertion that people constantly infer what goes in another's mind based upon their observation of their behavior. So I can't see what's going on in your mind, so I watch your actions and I infer what I think is going on in your mind, right? The idea behind, and in this particular idea, we're going to look at 2 types of it, right? And so the actual logic is like this. Here's the rationale. Trust repair strategies are likely to be more effective when humans believe that a robot can have its own emotions, intentions, or beliefs. For example, apologies are more likely to be more effective when humans believe robots can feel remorse or regret. Does that make sense? Does everyone buy into that logic? Right? Is it right? It kind of goes with what you were saying, right? To what degree people see this as a real thing? Okay, so here we go. This is what we did in the study. So we used trust change. So after box 1 and 2, we measure the human's trust in the robot as a pause survey, and then the robot. Then you have box 3. It makes an error or not, and when it does, it engages in a trust repair. Then we give another survey to see to what degree there's a change. Now, if it was an effective trust repair strategy, we should see what? Between points 1 and 2. What should happen? Go up. We'll go up. It would be hell of a trust repair strategy, right? Ideally, it would be the same, right? Because like if you had trust on a scale of 1 to 7, if it was 6 before the error, and then after the error and trust repair is 6, that's considered to be trust repair. If it went up, it'd be even better, right? But that gives really no changes, right? And this is the stuff here. This is how this is set up. Here's an example of some of the items. When I see presentations, people are talking about measures. I want to see what you're talking about. Don't tell me what you did. Show me. Here's examples of the items we measured. Mind perception. We also measure trust. This is trust, right here, items we use. And we also use propensity to trust automation as a control variable. Right? Does that make sense? Okay. So here's study 1. So participants, 400 participants, 8 per condition, by Amazon Turk, age 36. The actual gender identified was sort of balanced. We paid them a living wage. I know at the University of Michigan, if you don't pay them at least what they equivalent to be $15 an hour, your paper may not pass RB. It definitely won't get accepted at most ACM journals these days. So yeah, so I just know that and take that very seriously. So here's our manipulation check, where we took the conditions between there was the perfect condition, and we compared it to the error with no repair. And the idea is that if indeed our trust violations had an impact, it would show up, right, with no repair. Now, because we're looking at data that's basically the difference, we analyze it two ways. We analyze it, of course, with Mancover, but we also analyze it with Crystal Wallace because of the fact that it could be non-parametric, right? We're not going to assume that it doesn't violate, our assumptions. So we do it both ways, and both ways came up with the same results. They're pretty easy.
I have a quick question. How much variation was there? What was roughly the difference in the mean on those questions for experiential and agentic mind? That kind of gets at the question of, are people actually thinking that this is...
Yeah. No, I think they were above the midpoint. Yeah, I don't want to tell you. They were pretty high. In some cases, they were really high. Surprisingly high in some cases. Wouldn't always. That's a good question. So so the effect actually did. It's amazing. Yeah, the effect actually did. Now I will show you. So what we did was, when they first started the experiment, we actually had them working with the robot, and then we actually collected their actual data on mind perception at that point, like 0.0. Yeah. So random analysis. Remember, we sort of hypothesized this three-way interaction, right, between trust violation, trust repair, and type of mind attribution, right? And here's the full analysis. And click the full analysis, we find these three-way interactions to pop up. However, if you do the actual models, you'll see that when you go past the two-way interactions, the additional interactions don't provide additional data. So when you go past that, the rest of these become non-significant, indicating that the best model to use is not the one with the three-way interactions, but the reduced model with the actual two-way interactions. And here we find interaction between repair and conscious experience. But we're going to walk through each of these anyway. So I'm going to walk through each one of these to kind of unfold it to give you a bigger picture. So here's the average effect on the experimental mind. So I'll walk through this. So here, this line is the apology. Huge impact on apology, right? So imagine this is 0. We're saying basically you got full trust repair. This is low experimental mind. This is high. You can see both apology and denial have a huge impact. Right? They're much more effective when people see the robot as capable of being able to observe. Being able to experience emotions. Right? Now, so we're promises. You see these differences, right? There's some difference. So here we got denial. It's significant than 0, sort of a little bit with no repair, not quite significant. And then you see promises actually a flat line. If you do this across every interaction separately, you'll see why the three-way interactions were not that important, right? They kind of behave the same. You see a little bit of difference here in this last reaction. But the impact is consistent through all of the errors, right? So each time, this effect remained the same. It's pretty robust, right? So if you do want to explore, and we did look at the impact of the agentic mind, you can see why, even though there was a three-way interaction, it wasn't really significant. What you see is over time that the apology become counterproductive. That apologies actually become, less effective or, completely negative, right? It hurts you, right? But you can see that with the big effect, which is why there's not much there. Does that make sense? So basically, mind attribution, the experimental mind, apologies and denials were more effective when the experimental mind was attributed to the robot. And it was the same over repeated trust violations. I thought that was unusual. We would think it was going to weaken a little bit. Agentic mind, we saw a little bit, but for the most part, there was not a whole lot there. Okay? Now, what are some of the implications? This is where I want to bring everybody together on here. So, some of the implications. So, it actually highlights the importance of separating the dimensions. Some people will say that you should combine them. Some people say there are 4 dimensions, so I want to make that clear. This is one version of the theory of mind and the mind perception, where they have 2, there are others, okay? But this is the idea that basically, I know there are others because a reviewer has his own version that I have to cite and say that there are other versions, and I'm pretty sure I know what it is,
Look, I'm sorry, okay?
Agency, so why didn't we find this, this autonomy, right? We're talking about not autonomy, but the agency. Why would the agency effective? Why did that do something, right? Well, so agency in the literature has been associated with attribution of blame and moral responsibility, right? So if you're talking about robots, some cases increasing the perceptions of their agency can be counterproductive if you want to repair trust. Make sense? Right? So here we go. So let's talk about the things we did learn. Encouraging humans to see robots as having greater degrees of conscious experiment. One, pros, as designers and developers, we can make apologies and denials more effective. Right? So that's what I like to see, right? The cons is that we can make them more effective, and so the cons that you can manipulate humans into trusting robots when they should not, right? If a robot makes a mistake, maybe it just doesn't know better. Maybe you shouldn't trust it. And if you trust a robot when it shouldn't, there are at least some circumstances where it can get you killed, and that might be problematic, right?
Yeah, unethical.
Unethical. So right, all right, hold on, wait a minute, because I got, I'm not finished yet, because is Liz here? Did Liz leave? I told Liz I was going to come back and talk about ethics and stuff like that. So always, as someone coming from business school, when I go to ACM conferences, I always get like kind of knocked for not talking about, not having a critical view of some of the technology. So over the course of my time in SI, I have adopted a more critical view. So other con is, in some parts of the world, this can be viewed as a type of deception to be avoided and rather to encourage, right? Robots don't have feelings. Robots don't have, right? So to what degree we're encouraging this, one person could say that in itself is a deception and you're wrong for doing that. All right? Here we go. Now, is anyone here an expert in human-machine communication? One person, good. Maybe two, okay, good, yeah. So this might be uncomfortable. Yeah, she said, yeah. So this might be a little bit. This could be uncomfortable at this point. So, so human-machine communication acknowledges the importance of expression and emotion. But there's a debate about the effectiveness of designs, because people say, well, even if the robot appears to have emotions, people know it's a robot. It doesn't have emotions. So the idea that you can say like, yeah, some people say, yeah, you can, you can't. Well, we sort of bridge that by saying basically to what degree those designs can encourage people to see the robot as having a conscious experience that can actually work. Right? Can actually work. Now, do you know anything about expectation violation theory?
Yes.
Oh shit, I'm in trouble.
It's not my specialty, so you're probably going to be okay. So, yeah.
All right, so I'm going to claim for the purposes of this presentation that it extends the expectation violation theory to human and machine communication, right? So it works like this. So basically, expectations expectation violations can be positive or negative. Well, I'm saying that when the robot apologizes, that could be a positive violation. And to what degree people see a robot as being sincere can be a reward variance, right? Yeah, and so according to that theory, it should make it much more effective. So we can look at this using that lens and perhaps extend, this theory to, we can extend the expectation violation theory to human-machine communication. Or at least until the reviewer says no and asks me to take it out of the paper. But yeah, so I believe that's the case, right? So once again, I thank my student Connor, his work and the Emerging Technology Group at Michigan. They designed actually software. We actually led the development, but they did all the coding, that kind of stuff for it and put it online. So we can either, one, I'm not sure how much time we have, I can start questions now or I can go to study 2 a little bit. Not sure how much time we have. Are you got questions? Go ahead.
I think most people mean very different things when they say I trust a person and I trust a machine.
Okay.
We use the same word, but if you interrogate them what they mean by that, okay, but say I trust you.
Mhm.
One, we all know that to err is human.
Mhm.
We all believe we are infallible. It has to do with that how likely you are to make an error,
Okay.
and how much I believe that you are trying not to make an error. Let's say.
I don't know
What
about
does it
that.
mean to trust? Okay.
Wait, so the trust, well, now remember,
Okay,
I
for
presented,
example, if
I
you-
presented the definition earlier, right? So we know what I mean when we mean trust.
What do you mean by this? Trust a person.
A willingness to be vulnerable to the actions of the other party. That's what now that's the definition that I
A
said.
willingness to.
Well, to be vulnerable to the actions of another party. That's how I'm defining trust in this presentation.
But again, when you talk about a person, I don't believe that people will use the same meaning if you interrogate them when they trust a person or when they trust a machine.
Okay.
For example, people have discussed how much more reliable AVs has to be than human driver.
Okay.
And an analysis by some leader in the industry says they have to be 1,000 times safer
Okay.
for people to trust AVs.
Okay. Well, I mean, but it's still
Okay.
trust, though, right? I don't disagree with you, but still trust. So we're not really disagreeing there.
I think you're overloading the word, and people mean different
Well,
things.
I think that there's, like, this is actually more coming from a student of mine who's looking at kind of trust, kind of in human AI interactions, and I think that there are some scales like that kind of. Oh.
Back here.
Okay, so I think there are some established scales that try to get at different dimensions of trust, particularly when it comes to AI and robotics. So like
So those,
system-like trust.
yeah, those measures are
human-like-
trustworthiness.
Oh, yeah. All right.
Right,
Another
right.
distinction.
Yeah,
okay.
they're like ability, benevolence, integrity, or reliability, right? Yeah, so I do agree with, I've seen some of those measures, I don't, they're a
It's
bit
trying to
problematic.
distinguish this idea
Yeah, yeah.
of trust in it as like a system or a
Well,
product
like-
versus like this anthropomorphic sense of like I'm already like granting this thing kind of personhood and kind of some level of humanity, and my trust is based on is contingent on that fact.
So
right?
remember, in this study, we use the theory of mind, so I've already calculated some of those things, right? All right?
Well, I mean, I guess just to build on that, I think the literature is finding that the bases of trust are the same, but how it's established is different, which I think gets a little bit to your point, like on what basis would you have cognitive trust, in an agent versus a
So
person.
your past experience.
Yeah, but one thing I wanted to mention, actually, a thought that came to mind for me is from like my prior life. I worked in market research for a little while before I went to grad school, and we studied customer loyalty in electrical, your electric company. And basically, the people who had the most trust in the electric company were people where something had gone wrong, but the company handled it well and apologized. And so, in some
No.
ways, I was wondering if, especially those who see an experiential theory of mind, and then this agent recognizes that they did something wrong and they apologize to you, if that's like actually reinforcing that view in some ways, in more ways than when they are primarily looking at the capability of the AI, and the AI screws up and basically goes, my bad, and which undermines your sense that it's capable, right? So anyway, I just
Yeah, I mean, some ways,
thought about
yeah.
that connection before you were talking about this, that the apology could have an effect in that way.
I'm thinking about Jamie Banks's work, and she looks at mind, morality. Her work is sponsored by the Air Force. Mind, morality, and trust in robots, and it is in those different scales. It's complex, right? And I think what's coming up in this discussion is the fact that trust was first conceptualized around human-to-human interaction, and now we're retrofitting it to a human-machine context. And so some people will push against that and say that, no, this is anthropomorphizing the machine, because trust should only be understood as something that can happen among humans. For a lot of human-machine communication researchers, we argue to break away those constructs from human-only scenarios. Because they occurred a priori does not mean we necessarily should see them only within those contexts. And so some of what you're seeing here is actually corresponds with Jamie's work as well. But I mean, this is an interdisciplinary argument. Like, people will come at me and say, it just kind of this idea of trust, or do they really communicate? And so I think there's this whole other conversation that's occurring here, and there's the I can never say the word
Authorization.
Thank you of trust, but then there's also this ontological assumptions built into all this research. Yeah.
Thanks. Really interesting, really quick. So we started with like psychological safety. I'm curious, do you have a sense for whether or not human employees may perceive like a lack of fairness and say like consequences for error rates that like their org would tolerate? So for example, in your experiment, I would say that's a relatively high error rate, like 3 errors in a 10 package thing. But as you may know, Amazon workers, they don't have that like tolerance level before they see like reprimands and consequences. So could you just like probably speculate or share how that kind of differential in forgiveness from like an org level could be informed?
So I mean, in this case, remember the robot is learning something new. There's a window of them learning new, right? And eventually, right? So I guess your question is like, according to human factors literature, the error rate has to be at least, I think it has to be like over 30% to make it aware to the human, right? So this is what this context here. But the organization, you think the organization would probably have a much lower tolerate, I would think. But then remember, in this case, the human is like the fallback driver.
Okay.
Right? So
Gotcha. Like the double check.
Yes.
Kind of thing. Okay, thank you.
That's a good point. But I would say this before I wrap up, is that this really gets to trust, not trustworthiness, which I think is the prelude to trust. But yeah, I think these are great questions. And hopefully, if there are reviewers in the audience, you would see how important it is.
Thank you.